Alright. Hi, this is my video, and I'm going to share the screen right now. Alright. Alright, so it's Miss Shirley, and today I will be teaching you guys adding with fractions. It's going to be a really fun lesson. We're going to learn a lot about fractions and how to add them. Is a fraction. So a fraction is a math concept that shows separate parts of a whole. And we use fractions every day in our lives, such as in the food we eat, and even it's important to know our fractions since we'll be using them every day. For example, like when we eat a cake, there's 4 slices and we split it between 4 people evenly. Each person has a 1/4 of the cake. The 1 represents the piece each person gets, and the 4 represents the total number of slices there are in the cake. Let's break it down and show you guys what I'm talking about. So as you can see over here on the right, there is a slice of cake like that is broken up into 4 pieces. So each person gets 1 out of the 4 pieces there are total. So so the 1 would be the A, and the B would be the 4. So A is known as the numerator. It represents how much out of the entire whole is being used. So how many pieces each person is getting. So in this case it would be 1. And B, which is right here, is called the denominator because it represents how many pieces there are as a whole. So as you can see, we have 4 pieces total, and it's 1 per person, so the total will be 1 out of 4 per person. You got it? Okay. So let's see some more examples of fractions. So fractions can have many examples. Let's look at this picture below. So as you can see this picture, the red part represents 1. So there's 1 strip of red, right? Just 1 entire strip. And as we move on to the orange, there's 2 strips. So because there's 2 strips, one of the strips becomes 1/2, so it's a half. So there's 2 halves, as you can see. And all of these pieces represent 1, but they are broken up into pieces so that, like, if you see the yellow, they're broken down into 3 pieces, which is why the bottom is 3. And the top is just 1 because they're individual pieces, but together they're like 3 out of 3, and then together they're 4 out of 4, 5 out of 5, and 6 out of 6, and so on and so on. But all those equal to 1 because they're the same on top as they are on bottom. So all the pieces are counted on as a total over the total pieces. All right. So as you can see, the bottom number of the fractions can really be any number. A good example goes back to the cake. Imagine a cake that was big enough to cut into 100 pieces. The denominator would then be 100, and the numerator on the top would be how many pieces we would focus on. So if each person got 2 pieces, sorry, the recording cut off, but there's 2 pieces of the 100. So if a person got 2 pieces, so we would have 2 out of 4 pieces of cake, because 1/4 of a cake plus 1/4 of a cake equals 2/4. And that simplifies to 1 out of 2 because 2 divided by 2 is 1, and then so and 4 divided by 2 is 2. So that means we have half the cake, as you can see in the visual on the right. So we were given 1/4 of the cakes. And because we were given another quarter, it equals 2 out of 4. So 2 quarters equal a half. So you can see, I know I simplified it, but the number on the bottom does not change because it still represents how many pieces make a whole, which is 4. So we're focusing more on the top pieces, which is the numerator, and adding to those. All right, so let's try some of these problems together. So we have 3/8 plus 2/8. So we learned that on the bottom, which is called the denominator, does not change. So we keep the bottom and we carry it over to the other side of the equal sign. And then we add the top. So 3 plus 2 is, 5. So we carry over the 8 on the bottom, since once again it does not change, and we're able to get 5 out of 8. Great job, guys. All right, since we added only the top part, which was 3 plus 2 equals 5, and we brought over the same bottom because the whole amount does not change, then we were able to get 5 out of 8. Does anyone have any questions? You guys are doing so well. Honestly, you guys understand the concept, and now we're going to try some problems on our own. I think that'll be really fun. Going to do this on our own for 5 minutes, and we'll review the answers once we're done. And these won't be graded, and I just want to see how well you guys are understanding the concept, and if a lot of people are understanding, we can go over it more in depth and see what we can do about it. But I think you guys should get the hang of it pretty quickly. So we'll just do it in your notebooks, and I'll be walking around, making sure everyone's on task, and hopefully everyone's understanding the problems. And if anyone has any questions, they can ask me as I walk around. And raise your hands. All right. Good luck. All right. Great job. Okay, so that was good independent practice. A lot of you were doing great. And we're going to go over the answers right now. So on the first row, I hope you guys got, so 3 out of 5 plus 1 out of 5 equals 4 out of 5. Because remember, we bring the top part together. We add the top part, but we do not add the bottom. We just bring it over. Same goes for 1 out of 6 plus 4 out of 6, which equals 5 out of 6. Awesome job. So here are some tips that we should try to remember when we do fractions. So when we're adding fractions, we do not add the denominator. So if the denominator was 3, so if the number was 3 out of 5 plus 1 out of 5, it would equal 4 out of 5, not 4 out of 10, because the bottom number does not change. Just like, remember when we talked about our example of the cake slices on the bottom? Those are the total slices, and that doesn't change when we add fractions. So we only carry the denominator over and add the top part, which is the numerator. And then always just remember that fractions represent a part of the whole picture we are looking at. So not only can we do it with cake, but we can also do it with like boxes and things like that. We can measure parts of things and count them, and they can become fractions. And that's the end. Great job, guys. Our sources, the Common Core standards, and the works cited page. Thank you.